Question number 7. Now this is about properties of different types of soil. So you told that the soil that cracks easily when dry has. Now in this case you need to know some of the properties of soil. So the soil that cracks easily when dry, that soil is clay. So in this case, clay soil, rough texture is sandy soil, small particles is clay soil, large airspace is sandy soil, and low capillarity is also sandy soil. So that soil should have very fine what? Particles as well, which is clay again. So you need to first identify what is given in question before you attempt it. Now let me look at clay soil. So what do you expect of clay soil? Small particles, fine or smooth texture, small air spaces, that is between the particles, high capillarity, poorly drained, and because it is poorly drained, it can easily get waterlogged. It has high water retention. It's also good for modeling. And the reason is because it makes the longest ribbon. It is also the heavy soil. And then because of that, to work on, simply because it is heavy. So that makes it very difficult to work on. And then finally, I may say that actually it is dark in color simply because it has more or much humus. Remember, the humus will determine the color of the soil. Humus here is the organic matter or the organic content of the soil. It has high organic content and that makes it dark in color. And there is one point that I may not forget here to say that it also has the slowest capillarity. There is this point on slowest capillarity and this point on high capillarity. Capillarity is high because water will rise in clay soil to the highest level. But it will not rise very fast because the particles are in contact and so are blocking it. So it will rise but very slowly until it reaches there. We are going to see sandy soil where it has very many spaces in between the particles. So water will rise very fast because nothing blocks it, but will not go far. So for this is clay and this is sandy. So for sandy soil we will say that the capillarity is low but fast, actually fastest but low. Here it is slowest but high. So you need to understand that. Remember, fast means speed, but low means level. Of course, sandy soil now, it's very simple. The particles are large particles, rough texture, large air spaces, low capillarity, but fastest, capillarity, well drained, or porous. You call it well drained or porous, meaning it has big holes or spaces in between. Then we talk of low water retention. It's good for construction, but it cannot make a ribbon. It cannot make a ribbon, and it is known as the light soil. That makes it also very easy to work on. So that is for the sandy soil. And then finally, to talk about the last type of soil, which is loam. This soil is a mixture of sandy soil. It's a mixture of sandy soil and clay soil. And so that means it is an intermediate. It is right between sandy soil and clay soil. Now that makes its properties to be moderate, because it tends to exhibit both properties of clay and those of sandy. So that puts it right in the middle. So most of these properties, like large particles, for loam we will talk of medium particles. You will also talk of moderate, like moderate capillarity, medium texture, medium airspace, moderate drainage, all that. So it's right between. But there are two things which are specific about loam soil that we should talk about. One, it makes the shortest ribbon. It is the one that makes the shortest ribbon. Remember that sandy soil does not make a ribbon. We stated that. And then another thing, it is good for farming. Because one, it will retain some water, but again it does not also get waterlogged, because its drainage is not too fast, but again it does not retain that water. So it's good for farming. That is that. We look at the next question. And now we are going to an experiment on soil properties. The diagram below shows the setup that was used to investigate a certain component of soil. When we heat soil, fresh garden soil, in a glass container, but there is this cold water which is put here. The reason why it is put is to bring in what we call condensation, so that we have a cold surface that will condense the vapor that is coming from the soil. So when vapor comes from the soil, it means that soil contains water that reaches the cold surface here, then it will condense to form what? Water bubbles. So it is simple. That is the experiment. So when soil is heated, we are trying to test the presence of water in the soil. But we have various components of the soil that we can test. So let me bring you to the components of the soil that can be tested. The first one is what we call the mineral salts, or it is also called inorganic materials in the soil. We have air, we have water, we have living organisms, and then we have humus, or what we now call organic matter. So mineral salts or minerals are called inorganic matter, but the humus is called the organic matter. So all these are the components of soil, and each of them can be tested. There's an experiment to test for the presence of each of them in the soil. So quickly, let us see how we can be able to test a few of them. Now the first experiment is how to test for the presence of air in the soil. So you put the soil in a container, add water to the soil. You will see air bubbles. Now the bubbles here will confirm to us that soil contains air. It is that air that has been displaced by the water, and so they are living. So that tells us that there was air in the soil. So it is as simple as that. How do we test for the presence of humus? Humus. Remember, humus we said is called organic matter in the soil. Here we can have two experiments. The first one, so here we can have two experiments. The first one, take the soil and put it in a boiling tube or in a container, and you heat strongly. Heat strongly. And then you will begin to see smoke with a very bad smell, like burning rubbish. Smoke with a very bad smell. Now that will tell us that there is something in the soil that is burning, because pure soil does not burn. And so we will then know that inside the soil there are organic materials or humus that is burning. That is the first experiment to test for that. Maybe second experiment, take soil and put in a container, and then you add water. When you add water to the soil, you will find certain floating materials here. The materials that will be floating on top of that soil. Now what will be floating, because pure soil should sink? And then again you will realize that the floating materials are organic matter. So that way we will know that soil contains organic materials. So you can do any of those two experiments. The third test is the test for the moisture or water. Testing for the moisture or water in the soil. So for the presence of moisture or water, the experiment has been done here. You take soil and put in a container and you heat it. So we ensure that we put a surface here, maybe something which is cold, something which is very cold. So we may put something that contains cold water, like the one that is put here. So you will realize that when you heat pure soil, we will have moisture rising in terms of water vapor. Then when it comes into contact with the cold surface, it will condense to form droplets of water. So when we open the lid, we will find water droplets. That confirms to us that this soil contains water. Reason? Because we didn't add any water to that soil. So understand that. The next experiment is to test for the presence of living organisms. Now living organisms, we know they take in oxygen and they give out carbon dioxide. Now when you take carbon dioxide and mix it with lime water which is just clear like normal water, it changes into something milky. And so that is the whole experiment. So you take a container. In this container, put lime water. And then in this lime water, take soil and cover it with some material. This is soil. You may put it in a Muslim bag. So we just put soil there in a Muslim bag, then we may cover that so that fresh air does not come in. Remember, if living organisms are in this soil, because that is what we are testing, they will use the oxygen which is in here, and then they will be giving out carbon dioxide. So when that carbon dioxide will be mixing with lime water, the color of this lime water will change. And so we will say that we expect to see white precipitates or white suspension in water, in that lime water. So the color will change to something whitish, like some water to which some little milk has been added. That confirms to us that the living organisms were in this soil, and so they gave out carbon dioxide which mixed with lime water to form white precipitates. That is the experiment. Lastly, how do we test for the presence of inorganic matter or mineral salts? It is simple. Take a tray, put soil on that tray, and then put it somewhere in the sun. And then stand somewhere and observe. So when you put it in the sun and you stand somewhere and observe, you will be seeing some shiny particles when they reflect the light from the sun. Now, because soil is dark and does not reflect anything, so definitely what is reflecting are the mineral particles which are in that soil. That is the experiment. So I hope with that you will know about all the experiments that we can use to test for the properties of soil.